Has a problem like this ever stopped you in your tracks before? Well, in this video, we're going over positive integral divisors, so let's do it. Alright, so there's two types of positive integral divisor problems. There's the total amount of positive integral divisors, and there's the sum of all positive integral divisors. So to solve both, we need to know how to. And for that, let's look at an example. So let's take the number 36. Alright, so the total number of positive integral divisors. So we need to know the prime factorization. So in this case, 36. So the prime factorization is 2 squared, which is 4, times 3 squared, which is 9. So 2 squared times 3 squared is the prime factorization. So now we take these exponents. So we have 2 as the first exponent and 2 as the second exponent. And we're going to add 1 to each of them. So 2 plus 1 and 2 plus 1. That's just 3 and 3. Now we're going to multiply them. So 2 plus 1 times 2 plus 1. That's just 3 times 3, and that equals 9. So that's the total amount of positive integral divisors. Now let's know how to solve the sum of all positive integral divisors. So we need to look at the prime factorization again. So we have 2 squared, and we have 3 squared. Alright, so we first need to raise the power by 1. So 2 squared becomes 2 cubed, and 3 squared becomes 3 cubed. Alright, now 2 cubed minus 1 over 2 minus 1. And now we multiply that times 3 cubed minus 1 divided by 3 minus 1. Alright, so 2 cubed minus 1, that's just 8 minus 1, which is 7. So 7 divided by 2 minus 1. 2 minus 1 is just 1. So it's 7 over 1, which is 7. So 7 multiplied by 3 squared minus 1, which is 26, divided by 3 minus 1, which is 2. So 26 divided by 2 is 13. So now we have 7 times 13, and that equals 91. And that's your answer. Alright, first, what is the sum of all the positive integral divisors of the number 24? Alright, let's use our formula. So we first need to know the prime factorization of 24. So 24 can be broken down into 2 and 12. 12 can be broken down into 6 and 2. And 6 can be broken down into 3 and 2. Alright, now we can't divide it anymore. So we take up the first number, which is 2. So 2, 2, 2. So the 2 comes 3 times, which means the first number is 2 cubed. Next, we have 3. So 3. 3 only comes once, so it's just 2 cubed times 3. So that's the prime factorization. Alright, now let's take this and solve for the sum of all positive integral divisors. So we need to raise the powers by 1. So this becomes 2 power 4 and 3 power 2. Now we need to put it into the formula. So 2 power 4 minus 1 divided by 2 minus 1 times 3 squared minus 1 over 3 minus 1. Alright, so 2 power 4 is 16. 16 minus 1 is 15. So 15 divided by 2 minus 1, which is 1. Alright, so that's just 15. So we have 15 times 3 squared, which is 9. 9 minus 1, that's 8. 8 divided by 3 minus 1. 3 minus 1 is 2, so 8 divided by 2. So 8 divided by 2 is 4. So 15 times 4 is 60. And that's your answer. Alright, next. How many positive integral divisors does the number 520 have? Alright, let's take a look at the prime factorization of 520. So 520, so we can divide this by 2, and that's 2 and 260. This can be further divided by 2, so 2 and 130. This can be further divided by 2, 2 and 65. 65 can be divided by 5, so 5 and 13. And 13 can be divided by anything. Alright, so we have 2, 2, 2. So that's 2 power 3, because there's 3 2s. We have 5 ones, and we have 13 ones. So 2 cubed times 5 times 13. That is a prime factorization. So if there's no exponent above the number, we can just assume that it's to the power of 1. Alright, so now what we need to do is, we need to raise the exponents by 1. So that's 4, 2, and 2. And now we just multiply all these. So 4 times 2 is 8. 8 times 2 is 16. And that's your answer. Alright, next. How many positive integral divisors does the number 2000 have? So let's find the prime factorization. 2000 can be broken up into 2 and 1000. 1000 can be broken up into 2 and 500. 500 can be broken up into 5 and 100. 100 can be broken up into 2 and 50. 50 can be broken up into 5 and 10. And 10 can be broken up into 5 and 2. Alright, let's start off with 2. So we have 2, 2, 2, and 2. Alright, so that's 1, 2, 3, 4, 2. So 2 power 4 times 1, 2, 3. So that's 3 5s. So that's 5 power 3. So we take our exponents, which is 4 and 3, and we need to raise them 1. So that becomes 5 and 4. And then we just multiply them. So 5 times 4 equals 20. And that's your answer. Next, what is the sum of all positive integral divisors of the number 72? Alright, so if we look at 72, we need to find the prime factorization. So 72 can be divided by 2 into 2 and 36. 36 can be divided into 9 and 4. And 9 can be divided into 3 and 3. And 4 can be divided into 2 and 2. Alright, let's start off with 2. We have 1, 2, 3. So we have 3 2. So that's 2 power 3. And we have 1, 2. So we have 2 3s. So that's 3 power 2. Alright, so now we take the exponents and raise them by 1. So that's 2 power 4 and 3 power 3. Now let's put them into the formula. So 2 power 4 minus 1 over 2 minus 1 times 3 cubed minus 1 over 3 minus 1. Alright, so this is just 1. So 2 to the power of 4 is 16. 16 minus 1 is 15. So that just becomes 15 over 1, which is 15. So 15 times 3 minus 1, that's just 2. Then 3 cubed is 27. 27 minus 1 is 26. 26 divided by 2 is 13. So we just do 15 times 13. 15 times 13 equals 195. And that's your answer. Next, how many positive integral divisors does the number 3150 have? Alright, so 3150. So this can be divided into 5. So 5 and 630. 630 can also be divided by 5. So 5 and 126. This can be divided by 2. So 2 and 63. And 63 can be divided by 7 and 9. And 9 can be divided by 3 and 3. Alright, let's start off with 2. We have 1, 2, so just 2, or 3 power 1, if we want. Then 3. We have 3 twice, so 3 and 3. So that's 3 squared. Then 5. We have 5 twice as well, so 5 squared. And then we have 7 once, so just 7, or if you want, 7 power 1. Alright, now we take the exponents. So we have 1, 2, 2, and 1. And we raise them all by 1. So this becomes 2, 3, 3, and 2. And now we just multiply all of these. So that's just 6 times 3 times 2. That's just 18 times 2. And that's just 36. And that's your answer. Alright, what is the sum of all the positive integral divisors of the number 42? So to find the prime factorization of 42, we can do this divided by 2, or we can divide it by 7. So 42 divided by 7 is 6, and 6 is 3 times 2. So now we have our 3 prime factors, so 2, 3, and 7. So since they only appear once, it's 2 power 1 times 3 power 1 times 7 power 1. Alright, now we need to raise all their powers by 1. So that's 2 squared, 3 squared, and 7 squared. Now let's put this into the formula. So 2 squared minus 1 over 2 minus 1 times 3 squared minus 1 over 3 minus 1 times 7 squared minus 1 over 7 minus 1. Alright, so let's simplify the denominators. 2 minus 1 is just 1. 3 minus 1 is just 2. 7 minus 1 is just 6. Alright, so we have 1, 2, and 6 for the denominators. Now let's look at the numerators. So 2 squared minus 1 is 4 minus 1, and that's 3. 3 squared minus 1 is 9 minus 1, and that's 8. And 7 squared minus 1 is 49 minus 1, and that's 48. So 3 over 1 is 3. 3 times 8 over 2. 8 over 2 is 4. 3 times 4 times 48 divided by 6. 48 divided by 6 is 8. Alright, so this simplifies to 12 times 8 because 3 times 4 is 12. And 12 times 8 is 96. And that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, do make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.